Okay, we have to prove that this primitive here is asymptotically like this function here when x goes to infinity. Well, this problem is easier than it looks, because if you remember the meaning of this, f of x equivalent to g of x when x goes to infinity, the meaning of this is that the limit of f over g when x goes to infinity is equal to 1. So this is actually what we have to prove. So proving this is identical to proving that the limit of the primitive, this one here, divided by this, so ex squared ex squared over 2x when x goes to infinity, that this limit is equal to 1. So we have to prove this. All right. Of course, if you try to calculate the primitive, this primitive you can't, because this primitive cannot be expressed in terms of elementary functions, right? So you have to resort to other techniques. So what is this? In principle, what is this limit here? When x goes to infinity, the upper, the numerator goes to infinity. The reason is that the argument here is positive. So you have it's actually larger than 1, right? So e t squared is larger than 1 for any x or any t larger than 0. Okay, if t is larger than 0, then this is larger than 1, which means that the integral from 0 to x et squared is larger than the integral from 0 to x of 1 dt, which is just x. So if x goes to infinity, this one goes to infinity too. And obviously this one goes to infinity, right? Because you have an exponential of x squared. So what you have here is an infinity over infinity indeterminacy. And one way to deal with it is calculating, well, using L'Hopital. And if we use L'Hopital here, you take the derivative of this and you get simply this function. And you take the derivative of this one, and well, this is a quotient, so you have the derivative of this one is 2xe squared, then you multiply by 2x, which is the denominator, minus 2 times which is the derivative of the denominator, times the exponential, and then divided by the square of the denominator, 4x squared. All right, let's simplify this a little bit. So what you have here is the limit when x goes to infinity. Then you have ex squared in the numerator. Then here, down here, you have, well, you can factorize things, right? You can factorize, well, actually, you can simplify 1 factor 2, right? If you substitute here by 2. And then you can factorize the exponential, okay, which is a common factor of 2x minus 1, 2x minus 1. And the denominator here, which is 2x squared, you can put it up here, 2x squared, right? Sorry, this is 2x, there are 2x here, so this is 2x squared minus 1. Okay, now this exponential cancels, and that simplifies a lot the calculation of this limit, because now you just have to calculate this limit here, and the limit, this limit is very easy, and the degree of this polynomial is 2, the degree of this polynomial is 2, the ratio of the coefficients is 1, so this limit here is 1, so therefore this is 1, and therefore this is true.